Hey mathematicians, today we're going to look at an example of your Unit 2 project, which is going to finish up Unit 2. This project is about data collection and analyzation. So for this project, we're going to make a table, create a scatter plot, analyze the data, and use the line of best fit that we find. So up here on the second page, we have possible research topics and links to data that you could use. So for my topic, I picked motor vehicle deaths, and I got my data from the cdc.gov. So to create my table, I opened up a Google Sheet. I made my heading for the X years since 1950, because that was the first year I found the data from. So year 0 is 1950. 10 is 1960, 70, 80, 90, 2000, 2005 is 55, 2010, 16, 17. And then the Y values are the motor vehicle deaths, and that's per 100,000 population. Then I highlighted this, I inserted my chart, picked a scatter plot, inserted the trend line, and asked to see the line equation as a label, and put in my R-squared value. All I did then was copy it and paste it back into the document. So here's my nice table. Years since 1950, motor vehicle deaths per 100,000, and my scatter plot with the trend line, including the equation and the R-squared value. Now you notice the equation is not in R-squared form. So when I typed it in, I went up to add-ons, went down to Hypatia, and clicked Insert Edit Math. Then I typed in my equation in slope-intercept form. Y equals negative 0.228x plus 27.3. So that means each year the number of motor vehicle deaths decreases, because it's negative, by 0.228 deaths per 100,000 people. The y-intercept of 27.3 means that the number of motor vehicle deaths in 1950, the year we started, was 27.3 deaths per 100,000. 0.858. So this means the linear correlation is strong negative. So remember, it's strong because it's greater than 0.7. So weak was 0.3 to 0.5, moderate was 0.5 to 0.7, and strong was anything greater than 0.7. So 0.858 is quite strong. And it's a negative because obviously the line is going down. So the other possible models that I could pick in my chart were exponential, polynomial, logarithmic. You'll notice that I typed these equations in y equals form. So again, I went to add-ons, clicked Hypatia, inserted the math. So it's a nice, easy equation to read. So the exponential equation will be y equals 28.6 e raised to the negative 0.0122x. And that had an r-squared value of 0.8. The polynomial function, this is a quadratic because it's squared. Y equals negative 0.002208x squared plus 0.0208x plus 25.2. That had an r-squared value of 0.904. The logarithmic equation was y equals negative 7.7 natural log of x plus 45.6. That had an r-squared value of 0.738. So all three of these other models are also strong. So this is where you look at the data and you analyze it. Okay, so based on the results, the best model would have been the polynomial model, because although all the models have a strong correlation, the polynomial model had the highest r-squared value of 0.904, means it's excellent. So what does my linear model predict will happen over the next 5 years, 10 years, and 25 years? So we're using the linear model because this is 9th grade, even though the polynomial model was strongest. 5 years, 10 years, 25 years means we need to plug in the values for the year into our linear equation. So for 2026, I plugged in 76 for x into my linear equation because 2026 is 76 years after 1950. The model predicted 9.972 deaths per 100,000. So for 2031, I plugged in 81 for X, and the model predicts 8.832 deaths per 100,000. And 2046, so X was 96. This is 96 years after 1950. That predicts 5.412 deaths per 100,000. You notice, obviously, these are all going down. So remember we said there's a difference between cause and correlation. Okay, so the time passing is not causing motor vehicle deaths to decrease. So what is causing it? So possible causes of this reduction in deaths could be due to increased safety features in cars, airbags, crumple zones, that kind of thing. Mandatory seatbelt laws, 1950, 60, 70, they did not have seatbelt laws. You do not have to wear a seatbelt. Tougher drunk driving laws. Police are getting better at pulling people over. Roadside testing. Stricter fines and jail time for drunk driving, loss of license, and increased driver training. So driver's education, getting your driver's license later, and more practice time. So these are possible causes for the decrease.